The last lesson for Unit 6 is Lesson 5, which covers Section 8-6, Natural Logarithms. And so this builds on the number E that we learned in Lesson 1, which was Section 8-2. So remember that we talked about that E is the number that's estimated as 2.72 if we round that 1/8 up, and can be used as the base for exponents. So if I have some function y equals e to the x, then its inverse is the log of base e, which is called the natural log function. So if we have y equals e to the x power, then log base e of y equals x is equivalent. So again, I just switched from exponent form to log form, looking at the base of our exponent was e, and then we switched the power and the value, so e of log base e of y equals x. And so this is commonly written as ln of y equals x. And so ln of y means the natural logarithm of y. The L stands for logarithm and the N stands for natural. So all of the properties that we've talked about throughout Unit 6 hold for natural logarithms. What we're going to do today is really kind of review a little bit of everything that we've done to evaluate and solve natural logarithm expressions and equations. So for example 1, we're condensing. We're writing a given expression as a single logarithm. So for example 1a, we've got 2 ln of 12 minus ln of 9. So if I'm condensing into a single logarithm, remember our first step is to move our powers to become exponents. So that means that we have ln of 12 squared minus ln of 9. After we've moved powers, we want to condense it as a single logarithm. So in this, our ln is going to combine our 12 squared. So we have 12 squared and we have 9 because these two things are being subtracted. That means we're going to have a fraction. So remember that the numerator includes the positive log value is going to go on top over the 9. Okay. So we have ln of 12 squared over 9. If we simplify, 12 squared is 144. And so if we divide 144 by 9, that means that we end up with ln of 16. Okay, so 2 ln of 12 minus ln of 9 is equivalent to ln of 16. For B, we have parentheses. So when we work with parentheses, we want to start inside our parentheses first. So I'm just going to copy down the 1/3 because that's going to stay there. If I have ln of x plus ln of y, I want to bring that together and make a single logarithm. I'm just going to copy down the minus 4 ln of z. Oops, I wrote lx. ln. And so since I have ln of x plus ln of y, that means I'm going to multiply them together. So I'm going to end up with ln of x times y as a single logarithm from what was inside my parentheses. Okay, so all I did was combine ln of x plus ln of y to become ln of x times y. So when we're condensing, we next want to move our exponents over to go onto the variables that are after our logs. And so that means we're going to have for the first part ln of x times y all raised to the 1/3 power minus ln of z raised to the 4th power. Remember that when we talked about this, we talked about that if I have something raised to the 1/3 power, that's equivalent to having the cube root of that something. So that means that we really have ln of the cube root of xy minus ln of z. Write it as a single ln. So we've got natural log of, since we're subtracting, we're going to be dividing by our z to the 4th. So the z to the 4th is going to go in denominator, and the cube root of xy is going to go in the numerator. Okay, so we end up with ln of the cube root of xy. So we'll apply. We just have a base e, which shows up as an ln, a natural log, instead of a log base e, which is kind of a shorthand way to write. For example 2, we're solving natural log equations. So what we did in the previous lesson when we solved general log equations. So what we're going to do here is we want to get it to become log equal to a number. That way we can switch it to become e to the number equals that something. Okay, so that's our kind of major idea, and I'm saying equals e to that number of something. Okay, sorry about that delay. So our idea here is we've got our ln of something equals a number is what we want to get. Right now we have this power that we need to move to the front so that we can eliminate it later. So we're going to have 2 times ln of 2x minus 4 equals 6. What we want to do with that 2 is eliminate it. So we're going to divide both sides by 2 so that we have ln of 2x minus 4 is equal to 6 divided by 2 is 3. So from here, what we want to do is switch from our ln form to our e form. So what I wrote up there in the glitch, we want to rewrite this as ln means base of e, so e to the 3rd power equals 2x minus 4. And so when we're plugging this into our calculator, so on our calculator, we're looking for a button that has e to the x. Usually it's above the button that says ln on it, so you might have to hit like second ln or shift ln to get there. We are calculating that value, so if I calculate e to the 3rd power, I'm going to get the value 20.086. And that's equal to my 2x minus 4. Okay, so I'm going to need to move up so that I can solve this. So what I want to do to get x by itself is I first want to add 4. And so when I do that, I get 24. Sorry, 24.086. I accidentally left out my 8 when I wrote that down there. Equals 2x. And so then to get x by itself, now we have to divide both sides by 2. So if we divide by 2, we get that x is equal to 12.043. Okay, so this problem has an answer of 12.043. Okay, so let's try another one. So it's similar in a that we've got a power. So remember, we want ln of something equal to a number, which means we don't have room for that power to be in our problem. So we need to move the power to the front. So we've got a 2 there times ln of our 2x equals 1. So to get ln by itself, we're going to divide both sides by 2, which gives us ln of 2x equals 1/2. Okay, so remember that when we switch this to exponential form, right now we have ln of something equals a number. Next, we're going to have e to that number equals our something. So our ln is the base of e. So e to the 1/2 power equals 2x. So remember that here we're going to use our calculator. And so this value, if I plug e to the 1 divided by 2 power, I end up with 1.649 as my estimate for 2x. And then if I take and divide both sides by 2, that tells me that x is about 0.825. Okay, so So remember, for these problems, the first thing we want to do is get ln of something equal to a number, and then we're going to switch it to exponential form, which means we have e to that number. So again, front side, we did writing the expression as a single log, which was using our properties. Then we solved the natural log equation, again, by switching to exponential form. Okay, so we're going to do some more on the back. So the back side uses e, so we're going to be using natural logs as we solve these equations. So if I have 4e to the 3x power plus 1.2 equals 14, my goal here is that I want to isolate the e. So I want to isolate the e to a number so that it's equal to some other value. Okay, so I want it to look like that. So if I think about e as just a variable, right, even though it's a number, I want to subtract 1.2 from both sides, which will give me 4e to the 3x power equal to 12.8. To get e by itself, I have to now divide both sides by 4. When I divide 12.8 by 4, I get 3.2. So e to the 3x equals 3.2. So once I do that, I want to then switch to ln, or our log form. Our log form is ln of whatever our value is equals our exponent. Okay, so we're going to take and switch this to ln form. So it's ln because I have a base of e, so ln of my 3.2 equals 3x. So I want to calculate ln of 3.2. So remember the way that the log button worked on your calculator? The way that you should get 1.163. And so remember that if you're using your phone, you have to hit the 3.2 first and then the ln. If you're using a calculator where it displays before you press equal, you're putting ln of and then 3.2 equals. So you should get 1.163. And this value is equal to 3x. So to isolate x, we need to take and divide both sides by 3. So 1.163 divided by 3 tells us that x equals 0.388. Okay. So what we did is we took and we isolated the e to our power so that we just had a value left over. And then we switched it to log form so that we could calculate the log and then isolate x. So again, a little bit of everything. The last problem that we're doing is actually a continuously compounded interest problem. So if I have continuously compounded interest, this is an A-PERT problem. So I'm using the formula A equals P times E raised to the RT power. Remember that everything in there except for E is a variable. Okay, so I want to kind of identify what they're telling me. So I have an initial investment of $200 is now valued at $254.25. The interest rate is 6% compounding continuously. How long has the money invested? How long has the money been invested means that I don't know the time. So I'm going to end up solving for T. So the initial investment is my principal. So this is P, so P is $200. The amount in the account is the now valued. So A is $254.25. Our rate is 6%. Remember that we have to write our rate as a decimal. So that means that really 0.06. So we move our decimal 2 places to the left, which means we have to add a 0. So let's plug those values in. So A is 254.25. That's equal P times, so 200 times E R times T power. Our R is 0.06. T is our unknown. So we're going to leave it as a variable. Now we have 254.25 equals 200 times E raised to the 0.06 T power. So we have an exponential equation like we did in example 3. Let's go ahead and solve it, meaning we want to isolate E and then switch it to ln. So if I want E by itself, I have to first divide by 200. Okay, so I'm going to divide both sides by 200. 254.25 divided by 200 is 1.27, and that's equal to E raised to the 0.06 T power. Now that we have the E with the power by itself, we're going to switch it to ln form. So this is equivalent to ln of that 1.27 equals 0.06 T. Remember that once we have ln of a number, we want to calculate that. So we're going to use our calculator to 1 to 7. We should get 0.239, and that's equal to our 0.06 T. And then finally, to get T by itself, we're going to divide by 0.06, which means that T is about 3.983. So if we're talking years, this is about 4 years. So I'm sorry for the glitches. Hopefully that was good enough. Come ask with questions if you couldn't follow. Sorry.